Hey, 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 from West Virginia, or somewhere. Are you getting tired of this? I'm enjoying the travel. I'm enjoying seeing new places, but what we definitely have in common, what we definitely want is joke of the day. So let's get into that. So why did the boy stare at his glass of orange juice for hours and hours? Because it said concentrate. The container said concentrate. Oh my gosh. Okay. Well, let's concentrate ourselves into multiplying complex numbers. Now, notice I've got a couple of complex numbers here, both in that standard form, in that mathematical model with the business in the front, the party in the back. We've got a real in the front, imaginary in the back. Real in the front, imaginary in the back. So notice that they're sitting up against each other. That indicates multiplication. Well, if that I acts like a variable, because remember, it acts like a variable until you see I squared, and when you see I squared, you think -1. So right now it's acting like a variable, kind of like an x. So if you had a plus bx times c plus dx, what would you do with that? Absolutely, you would FOIL. So that's exactly what you're going to do here. The rule is not going to change at all. You're going to FOIL this. So if that's the case, then I'm going to take a times c, and I'm going to get ac. I'm going to take a times di, and I'm going to get ADI. I'm going to take BI times C. Notice I took the first term, distributed it all the way through the second parentheses. I'm going to pick up the next guy, distribute him through the second parentheses. Remember, FOIL is I like to call FOIL the extended distributive property. Because basically, I'm going to take this, distribute it through the second parentheses. Pick up the next guy, distribute him through the second parentheses. So when I distribute BI times C, I'm going to get BCI. And then when I take BI times DI, I'm going to get BDI times I is I squared. And whoop, I squared's what? -1. So what I have back here is BD times a -1. And remember, what happens there is, I'm just going to multiply my BD by -1 and get a minus BD. So I have AC plus ADI plus BCI minus BD. Notice that here's my imaginary parts. So I'm going to put the imaginary parts together. I'm going to put my real parts together. So I'll put AC minus BD. And then I'll combine these up. And remember, when I combine those up, if I is acting like a variable, I can combine up those coefficients and I can say AD plus BC and keep the I on the outside. So this is what I will get whenever I multiply those complex numbers. Notice that even though this is very extensive, it's still a complex number in standard form. Here's the real part, here's the imaginary part. So we still have the business in the front, party in the back. We still got our complex number in standard form. Now, you could memorize this rule and you could say, well, I'm going to take these two, multiply them together. I'm going to take these two, multiply them together, and subtract them from the first product. I'm going to take these two and multiply them together. I'm going to take these two and multiply them together. I'm going to add those two and then put the I on the back. But wow, for me, that is entirely too much to memorize. So I'm not going to memorize any of that because I know ultimately, here's what I'm going to do. When you multiply complex numbers, FOIL them. So let's take a look at these examples that we've got. Now notice we don't FOIL here, but when that 4i is sitting right up against the parentheses, it still indicates multiplication. So I'm going to take that 4i and I'm going to multiply it here, and I'm going to say 4i times 12, and then I'm going to multiply it back here, and a positive times a negative is negative, and I'm going to do a 4i times a 3i. Now, 4i times 12, remember, I acts like a variable until you see I squared. So right now it's kind of acting like an x. It's like 4x times 12. Well, that would be 48x, so this is going to be 48i. And back here, 4i times 3i, well, 4 times 3 is 12, and I times I is I squared. Bam, there it is. When you see I squared, what do you think? -1. So this is a minus 12 times -1, and -12 times -1 is a positive 12. Now, is that in standard form? Do we have our mathematical model with the business in the front, the party in the back? No, we do not. We have our imaginary in the front and our real in the back. So we just need to switch that around so that it is in that standard form. Aha, there it is. There's our real in the front and our imaginary in the back. Okay, let's try a couple more just to make sure we feel very comfortable with this. So take a look and notice that in this one, yes, we are going to FOIL. We do have first, outer, inner, and left, or the extended distributive property. So I'm going to take the first term, I'm going to distribute it through the second parentheses. Negative 2 times 6 is a negative 12. Negative 2 times negative 2i. Now negative times negative is positive. 2 times 2 is 4, so I get a positive 4i. I'm done distributing the first term. Now it's the second guy's turn. Send him through. 5i times 6 is going to be 30i. And 5i times negative 2i. Well, positive times negative is negative. 5 times 2 is 10. I times I is I squared. Bam, there it is. I squared equals negative 1. So therefore, my negative 1 then is going to be a negative 10 times negative 1. And negative 10 times negative 1 is positive 10. And so now what I'm going to do is, once again, I'm going to combine up those real parts and combine up those imaginary parts. So negative 12 plus 10 will give me a negative 2. And now let's combine up those imaginary parts. 4i plus 30i will be a 34i. Is that mathematical mullet, that standard form with the business in the front, the party in the back? We got a real in the front, we got our party in the back, our imaginary in the back. Yes, that is our standard form for our complex number. All right, last one. Let's go for it. So what I'm going to do here yet again is FOIL, extended distributive property. Take the first term, distribute it through the second parentheses. 3 times 3 is 9. 3 times negative 4i, positive times negative is negative, so it's a negative 12i. Now I'm going to take this guy. I've sent the first guy all the way through the second parentheses. It's the next guy's turn. Pick him up and send him through. 4i times 3 is going to be a 12i. And 4i times negative 4i, well, remember, positive times negative is negative. 4 times 4 is 16, and I times I is I squared. Oh, there it is again. I squared is negative 1. So what I have is a negative 16 times a negative 1. And now I am going to turn this negative 16 times negative 1 is positive 16. And so once again, what I'm going to do at this point is I am going to combine up my real parts here. 9 plus 16 is 25. And I'm going to combine up my imaginary parts here. Negative 12i plus 12i. Oh, check that out. They cancel. And I'm left with just a real number. Now, notice the format of these. These are called complex conjugates, which in the next video we will be discussing the use of complex conjugates for dividing our complex numbers. But for now, the point of this, and remember I told you before, it's okay to start with complex numbers and end with a real number. It's perfectly okay. Matter of fact, there's lots of times you want that to happen. But my point in this video is simply to say when you multiply your complex numbers, it sounds very difficult. It sounds very compound because they're complex numbers. It's really not hard at all. You're just going to FOIL. You're going to use your extended distributive property. And remember, I acts like a variable until you see I squared. When you see I squared, what do you think? Negative 1. You turn it into a negative 1 and you carry on, combining up all those like terms. I hope it helps. Have a great day.